welcome to Tech with SaaS. In this video, we will talk about service mesh. Service mesh is used for inter-service communication in microservice architecture. But before we deep dive into service mesh concepts, let us understand typical challenges which we face in the microservice architecture as a developer. So as we know that like in the microservice environment, we call the services like based on the business requirement, and there might be multiple calls happening, right? For example, here you can see payment service is calling data API and other stuff. And similarly, we have some client, right? Maybe it's like a mobile or machine or maybe IVR that connect via API gateway to application. So this is fine, right? Developer is focused on writing the business logic, but there are some other cross-cutting concerns which are required for application. For example, the config management. So a lot of configuration is required, right? Like suppose you have hundreds of microservices, then you have to maintain that URLs and how you are going to call other services, like maybe which protocol you want to use, you want to use the HTTP or gRPC. So all those stuff we have to maintain somewhere. Then also security is a critical aspect, like authentication, authorization is also critical. That also we have to take care. Like whenever we are calling from one service to another service, at that time we have to make sure that the communication is secure. But I have seen in many applications that the application till API gateway is secured by maybe MTLS. But once we are inside a cluster, right? Inside cluster, the communication is not secure. Not a good practice. So ultimately, for a good application, we have to make sure that the security features are also implemented properly. Then maybe sometime any service is down for a moment, then we have to check on that retry logic and timeout logic, right? That also required from us to code, right? Then the monitoring and metrics. So whatever monitoring, suppose you want to know, okay, my service is performing good or is not performing very well. How about like volume handling, maybe logging aspects. So all those aspects, apart from the business logic, are overhead for developer, right? So developer has to uh, focus on those aspects more than the focus on the business logic. So it's not a good experience for developers because it is adding a complexity and repetition to each microservice. Because, for example, you have 50 microservices in your application. Then this config management, security aspect, retry logic, metrics, everything you have to code in all the services, right? So it becomes an added complexity and it becomes very difficult to maintain also. So challenge here is to basically give some tool or solutions to developer so that these non-functional requirements are created by some other thing. Like so, solution here is basically a service mesh. Service mesh basically is a sidecar pattern, and where all these concerns, right, like authentication, authorization, then data logics and communication configuration, these are maintained by a sidecar proxy. And our application is just focusing on the business logic. So all these things are abstracted away from the main logic, and they are put into the different software. Maybe I can tell you later, like what software we can use for this implementation. Like so, in a nutshell, sidecar proxy is a main component of this solution, and that handles all the inter-service communication. And also, like there are some third-party applications like Istio and HashiCorp console. Okay, so these are the some. I mean, there are many products which are being used. Also, all the configurations required to be done are taken care by admin, and developers can fully focus on business logic. They don't need to bother about the cost-cutting concerns. So they're like they can focus on the main thing, right? So let us see like how a service mesh works. So in default web service API interaction, the services will take care of everything. They will take care about the security aspects, authentication, authorization, configuration, rate limiting, load balancing, everything they have to take care by themselves because there is no component between them. So the developer has to code everything and either by the code or by the property files that maintain all these aspects. But when we are using the service mesh architecture, it becomes really easy because all these cost-cutting concerns are now they are become part of this sidecar proxy. So these are basically the abstractions going away from developer. So the sidecar proxy will maintain all the like security things, routing and the configuration, okay, load balancing. These things are taken care by the sidecar proxy now. So you will see that for every service, there will be a sidecar proxy attached. So now a service, suppose service A want to communicate to service B, then a service A will not directly call the endpoint of service B. It will call service B via the sidecar proxy. So now when sidecar proxy is going to interact with the service B via its sidecar proxy, it will maintain, okay, whether the traffic is HTTP or some other protocol we are using, or what kind of authentication we are using, like security aspects, everything, and also the endpoints of service B, everything is taken care by sidecar proxy. So the service is just having the business logic, and developer is just focusing on the business logic. So everything apart from that is taken care by the sidecar proxy. So in this architecture, every service will have a attached sidecar proxy, and this is called a data plane, right? So all data, like incoming traffic, everything is going through this sidecar proxy, and they will take care of all the aspects. And this whole data plane is controlled from the control panel. Basically, you can understand this by that it generates the sidecar proxies with some policies. Like suppose you want to use some policies like authentication, authorization, load balance. All policies are configured as part of control plane. Then it generates all these sidecar proxies, and these proxies will be attached to each service. So this is how a service mesh architecture works. The main benefit is that the developer can focus on business logic. Other concerns, security, rate limiting, load balancing, routing, everything is taken care by the sidecar proxies, right? So now the main component here are the data plane and control plane. Let's understand how they work and what are their purpose. So if you understand like data plane has like a lot of tasks it is doing in this whole architecture, like the service discovery. So suppose if you are onboarding a new service, right? So you have to maintain its endpoint and its cluster environment, everything. So that is taken care by the data plane. So it will know, okay, if these services are up or down. So that is everything like discovery part of services is taken by the data plane. Then also the health checking, right? So whatever the upstream services are working fine or are they are down. So all those health check endpoints, health check, heartbeat checking, right? And liveness report will be taken care by the data plane. Routing also, suppose you have many clusters of services, right? So which cluster can take up the request and where you route it based on the configuration which we already done. So those aspects also are done by the data plane. Load balancing also, once you know, okay, which cluster you have to use, then okay, which instance to hit that request. So all those routing, load balancing, then authentication, authorization, like okay, you want to use which kind of solution, like you want to use the MTLS solution or simple TLS, maybe you want to use OAuth or JOT. Okay, so all those security aspect also taken care by the data plane component. And then main thing is that okay, how your service is performing. Maybe all the traffic is absorbing or not properly, or there's some errors. All the factors which observability maintains, right? All the things like, because in this application, a lot of services are there. So it is important to measure the metrics and understand, okay, my service is performing well or below SLA or above SLA. So all those aspects are also taken care by the data plane. So it's a very critical component in service mesh architecture. So now, if you are want to understand, okay, how these two components are stacked together in this architecture. So let us understand, suppose you are building an application, right, and you want to set up a service mesh. So what you will do? You will do some configuration, right? Suppose you have property file where you, okay, I have these endpoints, I have this protocol, these routing logic, this that limiting logic. Somewhere you put some static file you will put like in the configuration settings. So from that config settings, the control plane UI or maybe some command line tools, uh, from that you can generate the logic, the policies via control plane UI. Then like all like the deployment strategy you want to use, like Kubernetes Docker environment, or you want to use the bare metal environment, or you want to use the VM environment. So all those the things, right? Deployment strategies. Then AAA, right? AAA means the authentication and audit. So these aspects, how you have to maintain routing, load balancing, all these aspects, policies, right? The policies are governed by the control plane. After these policies are written down by property files or by some UI or command tools, then you can generate the sidecar proxies, and these sidecar proxies are going to inherit these properties and attach to each service and then cater to all those requests coming from clients. So this is how those whole things stack together. So control plane and data plane, how they work together, right? So also like we have the workload scheduler and service discovery. These are also aspects like how you can schedule your workload, like suppose you have which is like a UVM environment or like Docker Kubernetes. So at that environment, you can schedule these things as well. So this is how you can understand these two component of the service mesh. And one more very good feature of service mesh is that suppose you have some service A, and you there is some also some changes happen to that service, and you are not sure. Okay, that may be backfire. Maybe some issues are there. Then what you can do? You can configure your app server in such a way that you can route some traffic to the older service and some to the newer service. So that's how you can configure the routing of traffic. Okay, you can put the traffic how it is going to be used, consumed by the older or the newer service. So that's how you can deploy the services. It's also called the canary deployment. So this is a very good way to test your new changes in the production. So I think that's it for the service mesh architecture. But typical environment if you want to see in production, right? Because in production, if for a big application, might be hundreds of thousands of services, right? So you can see this how it look like. So basically, for every microservice, you have a sidecar, and they are communicating with each other via this sidecar. So yeah, so this like just take conceptual design, conceptual view to you to understand how what is the importance of a service mesh, how it is helping our life to make it easier. So yeah, thank you. Thank you for watching, and see you next time. Please leave comments any or questions. I'll try to answer them. Please subscribe if you like the video. Thanks.